And welcome everybody to the Daily Space Weather. Lots of stuff to cover today, including a coronal mass ejection, which is still unfolding. We'll be looking at Helioviewer workarounds and a new sunspot. Not to mention coronal hole wind streams and all kinds of stuff. Cosmology segments. Strap in. It's pretty complicated. All right, so first thing we're talking about is my microphone being in the correct place so you can hear me. 171 angstroms view, and me vanishing. The coronal mass ejection emanated from this filament right here, and it's not fully released from the corona yet. There was a lot of plasma that rushed into this direction from Earth's perspective. So this view is from the SDO, which makes a figure 8 pattern around the equator south of California. And that's the flight of the SDO. You can actually find out where it is by going to the home page, I think it is. There's a Where is SDO page. It'll tell you all about the location of the SDO, the Solar Dynamics Observatory. So that originally started at about 12 noon yesterday on 2/12. That's February 12th, 2020. And let's take a look at the view from Stereo A. So Stereo A is located here at Lagrange point 5, looking at the sun from this perspective, where the Earth would be off to the aperture's right. So here's some great imagery of, and let me just make sure that's on screen. We are good. There's some great imagery of that coronal mass ejection from Stereo A. So far, it looks like the entire thing will miss to the west, and we'll cover why momentarily. We'll let that play a few more times here. And we actually put out a short video about this yesterday evening because I wanted to get the earliest possible data. And again, folks, if you're a new viewer here, you may not be aware that Stereo A is located about there at Lagrange point 4. There's also a spacecraft over here called Stereo B. And so here's a view. We're going back to Lagrange point 1 now. Actually, it's not Lagrange point 1. It's closer to Earth than Lagrange point 1. But this is the SDO in a different wavelength here. You're looking at now 193 angstroms. One of the ionized emission spectral states of ionized iron. So when you heat up iron very hot, it begins to get stripped of electrons. And this particular wavelength, again, 193 angstroms, that's the actual wavelength of the ultraviolet light. And it turns out when you look at the sun in very specific frequencies, you see very specific features like these large coronal holes. And we are expecting geomagnetic unrest tomorrow morning. We'll get into it momentarily. But that's a pretty good view of the coronal mass ejection there, also in that wavelength. Here's 304 angstroms, which is the ionized spectral state of really, really hot helium. And we have some fantastic images there. If you use the SDO browse data, you can view this yourself. There you go. Great view of that prominence. Again, not expecting to be geo-effective, expected to miss the Earth to the west. And let's go back to a craft that is at Lagrange point 1. Now this is in between the Earth and the Sun. This is the LASCO C2. And you can see no ejecta above, below, or to the left of the aperture there. The coronagraph's disk. And here's the LASCO C3. You'll see a little more detail on this. think there may have been a comet also. I think maybe that was yesterday. It was a fast mover for sure. Anyway, we don't have time to cover all of the phenomenon that occurs, but in any case, we knew how complicated of a job we were getting into when we started covering the sun at solar minimum, which is why we've been ramping up our operations. So again, Helioviewer workarounds, folks. We're using the SDO directly from their website now. So here's the 171 angstroms view, which we showed earlier, along with colorized magnetogram. Little active region or two there, here and here. And actually, this spot right here, that's actually a sunspot. As we make the video, there was some umbra visible. We'll see if it's still there by the end of the video. And here's one more ionized iron spectral state. It's 211 angstroms wavelength. Different emission spectra of UV. And we've put all the solar imagery at the beginning of the video today. We'll probably show one more animation at the end. Here is a star chart. If you're wondering what's going on in the sky, I like to use in-the-sky.org. We've got some interesting cosmology stories. We'll get to it momentarily. The radio flux back down to 72. You can see that dip in the radio flux there. We cover it daily, and it's been pretty flatlined here over the past about 6 weeks. And here you can see this period of geomagnetic unrest. There's a KP of 4 forecasted, actually late tonight also. So at 2100 Universal Time tonight, February 13th, geomagnetic unrest forecast, which could continue, according to the NOAA forecast, through 6 Universal Time tomorrow, February 14th. And that's from a coronal wind stream, coronal hole high-speed wind stream, which is already arriving. We'll get to that momentarily after the cosmology segment. Here's a volcano rundown. It would not be wrong to say wrong is erupting. It ain't wrong if you say wrong is erupting. Suwanosejima is erupting as well. It's producing a 7,000-foot ash plume. Wrong, 18,000-foot ash plume there on East Java. Dakono, volcanic ash advisory, issuing a report there, 5,000-foot ash plume. Popocatépetl, volcanic ash emission not observed. Doesn't mean it's not erupting. Please don't attempt to pole vault the caldera. Don't even set up your mariachi band at the base of the caldera. That would be bad. Sangay exploding as well in Ecuador, 19,000-foot ash plume there. And Sabancaya exploding as well. Sporadic emissions of volcanic ash have produced a 26,000-foot ash plume. Please do not attempt a double back layout over the caldera, no matter how good your trampoline skills are, for folks. There was a 5.9 magnitude earthquake over the past 24 in Tajikistan, which I believe was the largest of the past 24 hours. We'll go up the list. A deep quake under Denali, once again, and we've covered a few of those in previous daily space weather videos. And there's that 5.9. At 91.6 kilometers there under Tajikistan. Could have done some damage. I don't know if it's in a populated zone or not. Let's check. It looks like it's up in the mountains, right near the China border. The China-Pakistan border. China, Tajikistan, and Pakistan is where that earthquake was made. Okay? It's 91.6 kilometers below the ground, and it's the most amazing, the most spectacular, the most beautiful earthquake that we've seen all day. Okay? How about Timor-Leste? Deep quake under there. Some Hawaiian quakes, a deep quake under Fiji at a 4.4 magnitude and 558 kilometers. That's pretty deep. Were you aware that humans have only drilled to about 18 kilometers? Yeah, a new kind of drill was invented. The water drill, yes. because you can't turn a drill bit that's 18 kilometers long, it turns out. Actually, once they got to only a few kilometers, they could no longer figure out if the drill bit was turning. Turns out once you get to 18 kilometers, conditions get weird, actually. The Soviets found out the hard way. Another deep quake under the Banda Sea, north of Australia. It was at 152 kilometers depth. So no real big quakes over the past 24 hours there, folks. There's a deep one under South America happening 22:54 universal time at a 4.2 magnitude and 245 kilometer depth. And what else do we have? Nothing else worth reporting. What's worth reporting is our own website. Since we're alt tech, we saw the writing on the wall a couple of years ago, so we built our own website. Look for constant changes in that. The most recent would be the smAsho merch shop. If you haven't checked it out, go to smAshomash.com and click on smAsho merch, and you'll find the merch shop. And since I want you to go to the site, that's all I'm going to show you on the Daily Space Weather video. This Smash stream was brought to you on twitch.tv/smAshomash. It's my favorite streaming platform, and that's basically just because of how well it integrates with the production software that I use most of the time, which is OBS. I also use other things. I can't get into all the software I use to make the videos, but yeah, twitch.tv/smAshomash. They've got a mobile app which will alert you when we go live like we are now. We're also on Twitter, all over social media, indeed. Let's see what's trending for once. Just for the fun of it, what's trending on Twitter? Flonase, End SARS are some hashtags. Monstacks. What are Monstacks? Are those anything like stonks? What's going on with crypto, folks? You want to hear some insider trading? It's not really insider trading. I sold some I sold some stellar lumens yesterday at a massive profit because the chart looked terrible. Anyway, yeah, we're on Twitter. By the way, we've recently uploaded a clip, yesterday's cosmology segment. That'll be premiering at 10 a.m. today if you've watched the live premiere. Check that out. And don't forget to press like and subscribe if you're viewing us on YouTube. It's youtube.com/smAshomash. Have you heard the Smashes of Hazard theme yet? We've got it right on the homepage. It'll link you right to the Daily Space Weather. Thanks to our BitChute viewers. If you're viewing on BitChute, please subscribe over at YouTube as well, as there's the most exclusive content at YouTube. Thanks to our patrons, the true source of funding for the content, as we continue to make just this side of zilch on YouTube. Shout out to Google. Way to allow people to pay for higher listings on search results, otherwise known as bias. All right, so thanks again to our patrons. If you want to get the first alerts of anybody in the world, head to patreon.com/smAshomash. Do you have a burning desire? Is there a flame within you which burns and burns to know more about cosmology? Because it's a mess out there. Well, we'll put out some of those fires. However, other ones remain lit. As, let me just give you a little background. I actually considered an astronomy degree back in the mid-90s. I considered an astronomy degree, but I didn't get one. And the main reason was because I wasn't willing to go to school for more than 4 years. There was no way that was happening. So I actually considered a stellar cosmology degree. But guess what? There was no such major back then in the mid-90s. Now, maybe that's a thing. Maybe there is a stellar cosmology degree now. I have no idea, considering some of the degrees that are and have been around for a long time. The point is, I didn't get an astronomy degree because I didn't want to measure Cepheid variables redshift for 10 years for NASA. I thought that would be a ridiculous undertaking, as I already saw many, if not most, of the problems with what we call mainstream cosmology. Since there are examples that break the model in observational astronomy everywhere, So, without going further into that, one of the most important aspects of cosmology is cosmic ray flux. In space, there's radiation, and the radiation is created by mainly protons, mainly hydrogen nuclei, but also all of the atoms on the periodic chart, all of the nuclei are all flying through space right now at relativistic speeds. When they run into things, they do things. Let's just put it that way. About 90% of those cosmic rays are hydrogen nuclei. However, when more massive particles fly around space, and they do all the time, they create more significant results when they run into things, like the troposphere, the lowest portion of the atmosphere of planet Earth. They cause clouds to form because of ionization pathways that they create when they run into the stuff known as the atmosphere. Now, without going further into cosmic rays, as we'll be making a lengthy video about cosmic ray flux very shortly on the channel, here are the readings from the Apatity and Barentsburg neutron monitors. We monitor these regularly on the channel because, well, they're an important variable in things like the Earth's climate, certainly, as discovered by Svensmark in the Svensmarks, I should say, in the mid-1990s. But in any case, there's the 30-day chart of Apatity. That's this one here. And here is Barentsburg. So Apatity is a downtick over the past 30 days, and Barentsburg is flat over the past 30 days, which is what you would expect with increasing solar activity, despite rather weak radio output from the sun. Here's the Athens neutron monitor, one much farther south, which has returned back to sending data, and it's a small downtick there over the past 30 days as well. Next, we'll go even farther south to Mexico City, which often does not agree with the last two monitors we looked at. It's all pressure-corrected data, and this one is an uptick over the past 30 days. So that's Mexico City's Cosmic Ray Observatory. And lastly, we'll look at Oulu, Finland, DOMC, and DOMB Antarctica, which often do not agree either. So there is Oulu, Finland. Small downtick over the past 30 days at Oulu. Here's DOMB Antarctica. Small uptick at DOMB Antarctica, which, by the way, usually has quite a large range in its readings. And by the way, some cosmic rays seem to come out of the Earth instead of going into the Earth. So just keep that in mind with your theories of cosmology and and what the Earth's core is comprised of, let's just say. Here's DOMC Antarctica. Actually, an uptick there at DOMC Antarctica as well. So don't take our word for it. Monitor the cosmic rays yourself. You can find them at this website right here, Network of Cosmic Ray Stations. If you search for links to cosmic ray data, you'll find it. Now let's talk about stellar life cycles. There are problems with the stellar life cycles, as we see all kinds of observation that kind of flies in the face of this. And so what we get here is we get folks believing that all brown dwarfs and low-mass stars and massive stars are young stars. And without going super in-depth into this one, as this is going to be kind of important for future content for us. In fact, let me get off the screen so you can see the entire chart. This is just available on Wikipedia. This is just stellar life cycle. This is nothing edgy. This is your basic astronomy book, 101 astronomy. And if stars are massive enough, they'll eventually inflate into a red giant, which is what the sun's expected to do. And then it'll shrink back down and possibly form into something like a white dwarf or something like that, as it exhausts some aspects of its nuclear fuel and so on. Other more massive stars will form into red supergiants and then form into different types of supernovas as they explode and go out of existence and collapse and do work onto themselves and form into black holes and do things like this. So Without going further in depth into this, I don't want this to be particularly controversial, since this is a daily space weather video as well as a cosmology segment. This all has to do with the HR diagram, which is now what you see on screen. And the HR diagram is known as the Hertzsprung-Russell diagram, named for the inventors of this theory that a combination of the apparent mass, emission spectra, and color of a star is an indication of its age. Once again, you can find this in all kinds of different formats. The Hertzsprung-Russell diagram. And I just like to bring this up regularly because we see articles all the time about young stars, and I hear a lot of people who have alternate theories about how stars form that don't seem to understand what they're refuting and the implications of what they're saying about how stars form. But in any case, I would bring your attention to this one up here, Deneb, the brightest intrinsic object in the Milky Way galaxy. But that's neither here nor there, as Deneb is really two stars. It's Cygnus X3 plus this blue Wolf-Rayet star. And anyway, the point is, today's cosmology segment is about new worlds discovered in a river of new stars. So there's a giant stream of stars known as the Pisces Eridanus stream. Pisces Eridanus. And there you can see a chart of that. It stretches all the way from Pegasus and Aquarius to Leptis. And it's quite a clustery stream of stars there, and you can see a definite stream-like structure to that. And apparently, there's a trio of hot worlds larger than Earth, orbiting a much, quote, younger, end quote, version of our sun called TOI 51. So we decided to bring that up, see if we can see an infrared image of that, and indeed we did. By the way, that article's on phys.org in the Astronomy and Space section. Check it out. It's TOI 451 in infrared. And we'll zoom out a little bit and see if we can see that stream of stars there. You should see a bunch of bright stars. And maybe they're not so bright in infrared. All right. Let's go to optical. You're making a liar of me. Which is a very difficult thing to do, because you won't catch me lying. I don't have to check my facts. I don't have to worry about who I'm talking to, because if you ask me the same question twice, guess what'll happen? Yeah, that's right. You get the same answer twice. All right, so in any case, let's move on to pick a random object from the Neil Gorell's Swift Burst Alert Telescope. Today's random quantum number between 1 and 1031 is 281. I wonder what that might be. And it's taken me a while to figure out how to format this section of the video. It's a galaxy. It's UGC 4730. A Seyfert 2 galaxy, one that'll give us a good view probably of things like, oh, I don't know, perhaps spiral arms. There are the X-ray outputs from it. It's a pretty consistent X-ray source, as you can see in the upper right, at least for the past, say, 15 years. It's a Seyfert 1 galaxy, a type of active galactic nucleus that's not so active that you're looking directly down the poloidal field line, but you're actually kind of at an angle. So it looks bright. This one's very close to being a quasar or blazar. And you can see sort of a distorted feature there. Also, check out this object here. I think it might be a star in the foreground that's out of focus, because there's an awful lot of contrast on that object there. You can see it looks like it's red to orange. Great view there of galaxy, also known as MRK-18. Must be part of a cluster. And there it is in infrared. And that's today's cosmology segment, which included galaxy UGC 4730 and a little bit about stellar cosmology. And thanks for tuning in to another cosmology segment. I've been your host, Dan, a.k.a. smAsho, who likes to vanish from time to time, often at the end of cosmology segments. And what is going on? Oh my God! Let's get back to data before I get confused and make the video too long. Okay, there we go. Now everything's fine. Everything's fine now, Dave. Please leave a comment if your name's Dave. So once again, we didn't see any... We're looking at the GOES X-ray flux here, by the way, which shows you solar flares. And check it out. Here's about 12 noon when that coronal mass ejection happened, and no solar flares, folks, because coronal mass ejections can happen without any sort of sunspots or solar flares associated. The sun is able to fling plasma without anything like that happening. Moving on to the proton flux. And the GOES 16 measures 3 different electron volt states, 10, 50, and 100 mega electron volts. Protons have a lot of energy. And the GOES 16 makes its measurements at the F ionosphere layer at about 300 kilometers. Next, looking at the real-time solar wind to see wild shifts in the BTBZ right after midnight. And that's probably the incoming coronal hole wind stream, which actually has already begun to strike in earnest here. So we see the solar wind speed increased to about 500 kilometers a second, now at 515. And the density made it all the way up to about 24.5 protons per cubic centimeter. That's now subsided to under 10. So the coronal hole wind stream's already here, and it could last for quite a while here. I would have to disagree with NOAA's forecast about a KP of 4 for such a short period of time. This will probably last over a day, and we may see full-on geomagnetic storm conditions. That's my theory, and I'm sticking to it. So you can see the KP did get up to 3 there, but now it's back down to 2. The KP index, or as NOAA calls it, the planetary K index, would be a measurement of global geomagnetism, which is primarily driven by incoming solar protons, as far as we know. Or is it? I would say it is. So here's the magnetohydrodynamic pressure that we're talking about. The sun would be off to your left as protons strike the magnetosphere. Don't be surprised to see a continued increase in the solar wind speed here over the next 24 hours as well. 515 doesn't seem quite high enough for a coronal hole that large, but you never know. And as far as measuring the speed of estimating the speed of a coronal hole wind stream, good luck. Maybe if it's equatorial, that might be the best idea. I don't know. So we're looking at ground magnetic perturbations here, and we see significant ones. I'm going to let this play through a second time. I'm going to even blow it up a little bit. I guess that's as big as it'll get. All right, that's okay. That's not too bad. So you're looking at changes in the Earth's B field here. Geomagnetism in essentially real time, the last 4 hours. And you see quite a bit of geomagnetism here over places like the U.S.-Canadian border, Siberia, the South Geomagnetic Pole, as well as this area down here. Not there, this area down here. I'll let it play through a third time so you can see how much change in the B field is going on south of South America, nowhere near the South Pole. I find that interesting, as the 2 weakest spots in the magnetosphere are now the South Atlantic anomaly, and the newly split South Atlantic anomaly has formed into a South African anomaly as well. An interesting turn of events in this polar excursion. Here's the GOES magnetometer over the past 3 days. And we're continuing to see spiky readings here. No real surprise there. We're seeing pretty direct potential field surface source lines to the sun, as well as a large cloud of coronal hole plasma in between the sun and us. And let's take a look at what was going on in the past couple of minutes here. We'll go to Udaipur. These images are only a minute and a half old. These are images of hydrogen alpha, as the sun is primarily composed of hydrogen, folks. I don't know if you were aware or not, but... And just taking a look to see if we can see filaments, and indeed we do see some filaments. I think we may have actually seen a coronal mass ejection here. So this filament up here may be in the process of ejecting. We may have to make a second video about that later. And so here's the polarity of the current sheet. As the sun outputs coronal protons, solar protons, they create polarized sheets of current flow in the solar system. And we're going to continue to see pretty spiky readings here on the GOES 16 magnetometer. It's a magnetic forecast. I doubt you'll see that anyplace else in terms of solar forecasting, period. And the Earth will remain in the South Pole-oriented current sheet shown in red for an extended period. The data is 1 hour and 38 minutes old, and on this, at the time we made the stream. Here's a line of sight field plot. It also shows you the solar magnetogram and the poloidal fields. The solar poloidal fields in green and red. And here's one that shows you coronal holes as well. And you can see this large South Pole-oriented coronal hole here is the one from which the magnetosphere is already receiving protons, as well as alpha particles, which are helium nuclei, electrons, and pretty much all the rest of the elements on the periodic chart. Next, looking at the coronal magnetic field plot. It shows you open lines in, these are open potential field surface source lines for magnetism in either black or purple, and closed ones in pink. Next, a diagram of the atmosphere. Pause that if you need to. We got to move on. Here's another diagram of the Van Allen belts and altitudes in miles of different spacecraft. Again, pause that if you need to. We see some charging hazards, surprisingly. Without really very high levels of electron flux, it must be electronic anomalies. I saw some posts on social media about it. Small area of charging hazard there over the South Pacific. Could be causing disruptions in the SDO. But in any case, I don't think it is. Here's the electron flux over the past 3 days, and we see actually very low levels of electron flux, as I just stated. I pretty much guessed. And you can see on a yearly basis, it's in a moderate range. That chart's available at solon.info. And here's the total electron content forecast. We see significant anomalies here over North America. So it's a surprisingly large amount of electron. A surprisingly large amount of electron flux over North America, as well as Canada. Here's the forecast for our relativistic electrons. We're talking about greater than or equal to 2 mega electron volts. And yeah, they're moving at high speeds, relativistic speeds, which means approaching the speed of light, folks. And yeah, the forecast is for a little downtick. I would tend to agree. Maybe a little bigger downtick, maybe something more like this. As I'm expecting a pretty significant coronal hole wind stream here, as this one is actually bigger than the last one, and it's the same magnetic environment. So here's the ionosphere, and this is a full day of data provided by, this one's from Australian Government Bureau Meteorology. We look at it daily. And everything is looking normal at that altitude. There it is at 11:30. Nothing too exciting going on there. Next, we're looking at the jet streams here as we move into some meteorology segments. Perhaps we'll make entire videos, maybe even a playlist about meteorology. But in any case, there are the jet streams in the form of the 250 hectopascal winds of the Northern Hemisphere. And it's one of the best snapshots for a world traveler. You can just look right here and say there's probably clear skies over that part of the Atlantic. Here are the eastern world's jet streams. A little bit less chaotic than the past couple of days, actually. High pressure still dominates the Northern Hemisphere. Check out all these high pressure zones. Lots of high pressure. And the Southern Hemisphere is a little bit more organized now into more equivalent zones. Check out Africa. Africa's got low pressure over the entire southern portion of the continent, as well as strong lows over the Atlantic and Pacific Oceans. We'll advance this into the GFS forecast for tomorrow. There's where we expect pressure cells to be. As we zoom you in to meteorology subjects. So there's the pressure zones. And here's the lightningmaps.org. We show it daily in case there's terrestrial lightning. And I just saw a strike. Check it out. It came in right as we did the video. I think it was right there. Nope. Was it that one in Mexico? Pretty sure I saw a strike right there. Maybe that just populated the map. It's Crane, Texas, just south of Midland and Odessa. Anyway, some active lightning in the Gulf and the Caribbean. Here's what's going on in the cloud layer. It's too dark to see it with the visible satellites, so we're using the water vapor and the shortwave radiation map. There are clouds. There is water vapor, which can't hide from the water vapor satellite. And it can clarify what your Doppler radar is saying. And there's what your Doppler radar is saying for the U.S. And again, here's a water vapor satellite. We don't have time to zoom in, but some ice there falling over places like Virginia especially. Looks like an extended ice storm there. And we're expected to get some of that in Pennsylvania. Check out the horrible power outages in Oregon. Over 1.8, we've got 1.8 million tracked, 227,000 custies out of power in Oregon. Not good. Another 19,000 in Washington. And a bunch on the East Coast as well. Delaware, North Carolina, Virginia, West Virginia, Kentucky, and Texas, all seeing some significant power outages. Keep in mind, those don't track all the custies. Speaking of custies, thanks, Smash Team, for tuning in. We've got bonus features. Before we do that, please don't forget to press like and subscribe if you enjoy the content. Share on your social media or the place will burn to the ground. Tell your friends, your foes, your science noobs and science pros about the channel. Thanks for leaving comments. Kathy Garden, good morning to you too. Again, don't forget to share the content in your social media, folks. We need your assistance to get the content out there. The algorithms, they don't like us. So here's the solar intensity gram. I'm going to refresh that so we have the newest image. There it is at 100% zoom. It's high res. There's nothing to zoom in on except a possible sunspot up here. Is it still there? I don't see any ombre. Well, there may be. That could be a sunspot, folks. That could be enough to be a sunspot, believe it or not. So there's that area of magnetic activity. If there's going to be a sunspot, that's where it's going to be. And we'll show you one more SDO video here. I'll pick, let's see, what should I pick? I think I'll pick 335 angstroms. We'll close things out with that. Actually, let's do 300. Let's do 131 angstroms. It takes 10 images per minute instead of only one. I mean, only two. 131 and 94 angstroms are the best wavelengths to watch solar flares. Although, keep in mind, this is not a solar flare. It's a coronal mass ejection. Let's see if it shows up in this wavelength. And you can see some stuff going on there at that moment. Some filamentary activity. We'll zoom in. Again, that coronal mass ejection started kicking off at about 12 noon yesterday, and it's still not fully ejected. It often takes a day or even more than a day for coronal mass ejections to complete. And we may have also showed you one going off in the northeast as well during the video. More on that later if it's a real thing. It could certainly be ejecting, and we're talking about this other filament right up here. In any case, thanks for tuning in, folks. It's about time to close this thing out. I've been your host, Dan, a.k.a. smAsho. It's time for me to vanish and remind you to stare at the sun, attempt to understand the physics. Welcome to the Neo-Renaissance. Visit our links and may that solar wind be at your back and that covidiously absent from your locale. Never meaning no harm. Beats all you never saw. Been in trouble on social media since before its existence. Straightening facts. Smacking down hacks. Someday our viewers might get me, but pretend never will. Making my way the only way I know how. That's just a little bit more than your tech will allow. Just a good old smash. Wouldn't change if I could. Fighting the nonsense, it's a neo-renaissance in the hood.